This Navy minesweeping launch is driven by a gas turbine engine, the Boeing 502-10C. Another 502-10C is used to power a magnetic minesweep generator in the launch. It is designed to burn diesel fuel, but if necessary can be operated with kerosene or jet fuel. The engine's output rating is 209 horsepower, yet the total weight of the engine and its accessories is only 325 pounds. The operating principle of this engine is fundamentally the same as that of all gas turbine engines. It is based on three primary components: compressor, burner, and turbine. The 502-10C has these components, but it uses two burners and two turbine wheels. The engine is a two-shaft design and can be divided into two sections: the gas producer section and the power output section. The gas producer section consists of a single-stage centrifugal compressor, two cylindrical burners, and an axial flow turbine wheel. The gas producer does not produce mechanical power output. Its function is to produce energy in the form of hot gases that go to the power output section. It consists of an axial flow power turbine wheel, reduction gearing, and the power output shaft. It is the purpose of this film to show the construction and operation, together with some of the maintenance, of the Boeing 502-10C gas turbine engine. The construction of the engine is best seen with the assistance of this full-size demonstration engine, which has certain portions partially cut away to show internal parts. The right half, or second stage of the engine, is the power output section. The left, or first stage, is the gas producer section. This is the inducer, which serves to draw outside air into the impeller. The impeller blades drive the air outward through the diffuser sections and into the compressor case. Here the pressure of the air is about 4 atmospheres. Leaving the compressor, the air enters the burners. Each of the two burners consist of an outer shell, a liner, and a dome assembly. In the dome is the fuel nozzle. This is the igniter, which is used only for starting. Beneath the burners are the igniter plugs. They receive their power from this capacitor discharge ignition unit. The burners are connected by piping known as the crossfire tube. The tube enters each burner at the bottom of the liner. Thus, if one burner fails to ignite during the starting period, the crossfire tube will carry flame from the fired burner to the unlit burner, causing ignition. As the hot gases leave the burners, they enter the nozzle box. Here they are directed by stator blades to the turbine wheel. As the compressed gases expand, the turbine rotates, reaching a maximum speed of 37,000 RPM. As the turbine wheel turns, it drives the inducer and impeller, which are mounted on the same shaft. This draws new air into the compressor, and combustion is maintained. The accessories in the gas producer section include the fuel pump and fuel control governor, mounted on the accessory gearbox. Also mounted here is the engine tachometer generator and the starter motor. The lube oil filter is located on the underside of the engine. Behind it is the lube oil pump. The pump is a combination pressure and scavenge unit. This simplified diagram of the engine lubrication system will show how the pump unit distributes oil to various parts of the engine. The pressure pump takes oil from the sump in the gas producer section and sends it through a cooler through which seawater is circulated, then through a filter, and into the two sections of the engine for lubrication of the bearings and gears. The oil also goes to the speed control governor. A relief valve is used to regulate engine oil pressure. The scavenge pump takes oil from the sump in the power output section and sends it to the sump in the gas producer section. Now let's consider the construction of the second stage of the engine, or the power output section. This is the nozzle ring which receives the combustion gases from the first stage. Stator blades direct the gases against the power output turbine wheel. Leaving the wheel, the gases are discharged into the exhaust collector and then to the atmosphere through the exhaust stack. The reduction gear unit provides an 8.9 to 1 speed reduction between the second stage turbine wheel and the power output shaft. This shaft is coupled to a reversing reduction gear and a V-drive which drives the propeller. The accessories in the power output section include the speed control governor, the throttle lever, a propeller tachometer generator, and an overspeed switch. The principal steps in the operating procedure of the Boeing 502 engine are given on a placard attached to the control box. The operator should be thoroughly familiar with these instructions, which may also be found in the engine manual. Before starting the engine, inspect the engine and the surrounding spaces for fuel or oil leakages. Check the oil level. And open the main fuel supply valve. The throttle and gear shift lever should be at the neutral position. To make sure that the electrical circuit breakers are closed, press the two reset buttons. The remaining steps are taken at the control panel. All switches should be in the off position. Now turn the master switch on. The fuel boost pump will start and the 3 oil pressure warning lights will go on. Gear lube, clutch oil, and engine oil. Check the operation of the warning horn. Then leave the starting switch off, but for starting purposes only. Next, press the warning light test switch to make sure the warning lights for exhaust temperature and engine oil temperature are functioning. The oil pressure gauges should read 0. Everything is now ready for the actual starting. For a normal start, set the selector switch to automatic and press the start button. After 5 to 7 seconds, the starter motor will turn over. At 4,000 RPM, the fuel is injected and ignites. As speed increases, oil pressures will rise and the 3 oil low pressure warning lights will go out. When the last has done so, turn the warning horn switch on. At 15,000 RPM, the engine is at its normal idling speed. To complete normal starting procedures, see that water is flowing from the oil cooler overboard drain. The launch is now ready to get underway. For a more complete understanding of normal starting procedures, let's see how the automatic start cycle works. Inside the control panel box is the automatic starting controller. This schematic diagram will show in general how the controller works. When you close the master switch, this part of the circuit is energized. Then when you turn the manual automatic selector switch to automatic, The circuit is energized up to the start switch. When you close this switch momentarily, a power hold-in relay operates to close the starting circuit. The start switch is now bypassed and can be released. The current flows to the ignition relay. This closes the circuit to the igniter glow coils in the burner chambers. The coils start to heat up. Current also flows to the speed sensor. The circuit includes a timer that provides for automatic shutdown in case of malfunction. From the timer, the current goes to a time delay relay. It is designed to close in 5 to 7 seconds, allowing sufficient time for the igniter glow coils to heat up fully. When the time delay relay closes, current flows to the starter relay, causing the starter motor to drive the compressor with the first stage turbine wheel. This, in turn, causes the engine tachometer generator to send a signal to the speed sensor. When engine speed reaches 4,000 RPM, the speed sensor sends current to operate the fuel solenoid valve, admitting fuel to the burner, and combustion is started by the igniter. The engine accelerates. When 12,000 RPM is reached, the speed sensor causes the starter relay to be de-energized, opening the circuit to the starter motor. At the same time, the ignition relay is also de-energized so that the igniter is shut off. The automatic start cycle is now complete, and the engine continues to accelerate to 15,000 RPM, the normal idling speed. During starting, certain malfunctions may occur. For example, if the starter motor turns over, but the engine fails to accelerate to idling speed, one or both burners have failed to ignite. This is called a false start. When it occurs, the starting system timer provides for automatic shutdown. Let's assume in this case that the igniter is not operating. 22 seconds after starting, the timer de-energizes the hold-in relay, with the result that the entire system is shut down. If this happens, press the start button again. Should the engine again fail to start, follow the troubleshooting guide in the engine manual. If during starting, the engine ignites with a heavy rumbling sound, accompanied by excessive exhaust temperature, a hot start has occurred. This is caused by late ignition of a heavy accumulation of fuel in the burners. When this happens, press the temperature reset button. If the excess fuel has burned off, the temperature indicator will drop back to normal and starting procedures may be continued. On occasion, a hot start will not correct itself and the exhaust temperature will fail to return to normal. When this occurs, first shut down the engine by turning the master switch off. Next, the raw fuel must be scavenged from the burners before another start is attempted. To scavenge, first turn the master switch on. Now move the selector switch to manual and make sure that the manual fuel switch is off. Hold the start button down. The fuel flow has been cut off and the starter motor will blow out the accumulated fuel in the burners. During scavenging, the engine oil pressure gauge should move slightly, registering about 10 pounds of pressure. After 8 to 10 seconds, release the start button and secure the engine. Restarting should not be attempted until 1 minute after the engine has stopped. After scavenging, manual starting procedures must be followed. With the selector switch still at manual, turn the master switch on and hold the start button down. At 5,000 RPM, turn the manual fuel switch on. Combustion should begin and the engine should accelerate. Engine speed should reach 15,000 RPM within 15 seconds. If it does not, secure the engine and repeat scavenging. At 15,000 RPM, release the start button and turn the warning horn on. The engine is now idling and ready to get underway. To get underway, the throttle and gear shift lever is moved partway astern or ahead. This couples the engine to the boat propeller shaft. When the lever is further advanced, engine speed is increased. Load changes that affect the propeller speed are compensated for by the speed and fuel control governors. During underway operation, the warning lights and the horn show that a danger exists. If low oil pressure is the trouble, the engine must be shut down at once and the trouble corrected. If overtemperature occurs, there is no cause for alarm. Reduce engine speed by throttling back. Then press the temperature reset button to check that the temperature has returned to normal. If throttling back fails to reduce temperature, shut down at once. To secure the engine under normal conditions, set the throttle lever to neutral. Let the engine idle for 1 minute. Then turn all switches off. First the warning horn switch, then the master switch, and all other switches. It will take about 1 minute for the engine to coast to a stop. Finally, close the main fuel supply valve. This completes the securing of the unit. Periodic maintenance, overhaul, and repair instructions are given in the engine manual. Periodic inspections are scheduled at 50, 100, 300, and 900 hours of engine operation. Here briefly are some typical inspection and maintenance items. At specified intervals, replace the lube oil filter element with a new one. After each burner liner has been well cleaned of carbon deposits by vapor blast, vapor degreasing, or stainless steel wire brush, examine it carefully for possible cracks. Small cracks do not make a part unusable, but if several small cracks are in line, they may readily join to make a larger crack. Never use a lead pencil to mark any of the hot parts of the engine. A grease pencil is all right, but ordinary pencil lead will cause cauterizing of the stainless steel and loss of the metal's resistance to corrosion. The burner dome should have the same close, careful attention. If small cracks have appeared, the part should be inspected again after 50 additional hours of operation. After soaking in an approved solvent, the fuel nozzle should also be carefully inspected. If it should be necessary to clean the hole, use a piece of soft wood, never wire or other metallic instrument. Check the condition of the sealing rings in the crossfire tube. Inspect the starter motor brushes. Look over all fuel and lube oil lines and the electrical wiring for any possible signs of trouble. This demonstration of engine maintenance has covered only a few points. The engine manual should be consulted for a complete understanding of required maintenance. The Boeing 502-10C gas turbine engine is characterized by its simplicity in principle and design. The construction of the engine follows the same simple ideas translated into a rugged, dependable piece of equipment. It is a power package that, given the proper attention, should serve well the craft and the commands to which it is assigned.